these are the notes for section 5.8. There's only going to be one set of notes for these. So it is on applications of polynomial functions. I'll just write applications of polynomials. So the main thing that we're going to use these polynomials for is we want to be able to factor them so that we can solve equations. So now we're going to work from just factoring into problems where we're going to need to factor it in order to solve it. So one thing we need to talk about before we can do that is the principle of zero products. So the principle of zero products is actually something pretty simple. It says if a product is zero, so that means if some numbers are multiplying up to zero, so some factors are multiplied together and the product is zero, the answer is zero. If that happens, that means that at least one of the factors must have been zero. Because if you get 0 as an answer when you're multiplying, you must have done 0 times something at some point. So, for example, let's say we were given a polynomial and it's already factored into x plus 3 times x minus 2. If we want to know when that polynomial is equal to 0, so we're asking what value of x could we plug in here and make that equal 0 when we multiplied it? Well, then we know that one of these two guys equals 0, because we had to do either x plus 3 times 0 to get 0, or the x minus 2 times 0 to get 0 as our answer. So we're going to use this principle to solve some equations in the next slide here. So our first example is we're going to solve this equation, x squared minus x equals 6. So before we learned how to factor, we wouldn't really have a way to solve this, except for guess and check. We'd have to guess what x could be and then try and solve it. Because we can't combine these because one of them is squared and one of them isn't, and there's no way to get x by itself if I can't combine them into one term. So what we're going to have to do is factor this. So our first step is going to be to get this equal to 0. So if we're solving a polynomial function, the first thing we want to do is set it equal to 0. So the first thing I'm going to do here is subtract 6 from each side of this equation, because that's going to make this side of the equation 6 minus 6, which is 0. If I do that, on the other side of my equation, I still have the x squared minus x, and then now I just have a minus 6 on the end. I can't combine any of those terms, so I just have to write them all out separately. So once we get it set equal to 0, now what we're going to do is factor just the side that's not 0. So for this factoring problem right here, I'm just looking for what multiplies to negative 6 and adds to negative 1. So we could do 1 and 6, or we could do 2 and 3. I think the 2 and 3 will work if we make the 3 negative, because 2 times negative 3 is negative 6, and 2 plus negative 3 is negative 1. So we're going to just factor this into x plus 2 and x minus 3, and it is equal to 0. So from that rule of the principle of zero products, I know that if these two factors multiply to 0, one of them has to equal 0. If either one of them is 0, the whole thing's going to be 0, right? If whatever x plus 2 is, if that's 0, then we're going to have 0 times x minus 3, and that's going to equal 0. So anything that makes either of those factors equal 0 will make the whole thing equal 0. So what we're going to do next is set all of our factors equal to 0. So I'm going to say, all right, if x plus 2 is 0, the answer to this problem is going to be 0. It's going to work. if x minus 3 is 0, the answer is going to be 0. So I just set each of those two factors equal to 0. So now these ones are easy. What plus 2 is 0? Well, negative 2 plus 2 is 0. That one was easy. On this one, what minus 3 is 0? Well, 3 minus 3 is 0. So x is 3. So I have two answers to this. My solutions are that x equals negative 2 and 3. Either one of them will work. And I want you guys to list them from smallest to greatest. So I list negative 2 and then 3. So let's try a couple more like that. Here we go. All right, so for our second example, we're going to solve 5b squared equals 10b. So if I wanted to solve this, I guess I could maybe divide by 5 on both sides. We could do that. I mean, we can do that. There's no reason we can't do that. We could divide by 5 on both sides. So we have b squared equals 2b. Now, if I didn't know how to factor, I don't know what I would do from here. I can't combine my b's together. I could get them all on one side, but I can't combine them together and then try and get b by itself. So what I'm going to have to do here is I'm going to have to factor it after I set it equal to 0. So let's go ahead and subtract 2b from each side of that equation. And then we're going to be left with 0 on this side of the equation. And on the other side, we just have b squared minus 2b. So we got it set equal to 0. Now let's try factoring this. So all the same rules of factoring apply. I can take something out of both of these terms. I can take a b out. So we want to go ahead and do that. So we're going to take a b out, and we're going to be left with b minus 2. And it's still equal to 0. So I have two factors here. My factors are b and b minus 2. If either of those are equal to 0, my whole answer would be 0 and it would work. So we're going to set both of these equal to 0. So for my first one, it's really easy. 0, because if b is 0, that whole answer will be 0, right? And if I go up to the top, that would work, right? 5 times 0 squared is going to be 0, and that equals 10 times 0. So yeah, 0 is one of my solutions. It works. And then we're also going to set this factor equal to 0. So we're asking ourselves, what number minus 2 is 0? Well, 2 minus 2 is 0. So I've got two solutions here, b equals 0 and 2. So we're going to write b equals 0 and 2. Either of those would make it work. All right, new example. So we are going to solve x squared minus 6x plus 9 equals 0. So this one's nice because it's already set equal to 0 for us. I think this one is a perfect square trinomial, isn't it? Because this is x squared, 9 is 3 squared, and my middle term is negative 2 times x times 3, negative 6x. It works. So this one is a perfect square trinomial. Remember, I can factor this into just x minus, because of that minus right there, 3 squared. So all I did so far was I factored the left side of my equation. It was a perfect square trinomial. Now in this one, I have two factors. I have x minus 3 times x minus 3. So if either of those are 0, it's going to be 0. You don't have to write out x minus 3 equals 0 and x minus 3 equals 0. It's going to be the same answer. So since it's squared, we only have to write it once. And we're asking ourselves, what minus 3 is 0? Well, 3 minus 3 is 0. So x equals 3. There was only one solution in this one, and that's okay. It's okay to only have one solution. All right, let's try another one. It's going to be a little more difficult here. So we are going to have two polynomials here. F of x is 3x cubed minus 30x, and g of x is 9x squared. So we have two polynomials here, f of x and g of x, and my instructions are going to be find a value of x for which f of x equals g of x. So I want to know, when are those two polynomials going to be equal to each other? So all we have to do is set f of x equal to g of x. So let's write that out. F of x is 3x cubed minus 30x. And I want to know, when is that going to be equal to g of x, which is 9x squared. So this is looking like a problem where there's not a really good way to solve it other than probably factoring it, because I'm never going to be able to get x all by itself, because there's x to the 3, there's x to the 2, and there's plain old x's. So let's get this set equal to 0 first. So I'm going to, from each side, we're going to subtract that 9x squared. So when I do that, this side of my equation is 0. On the other side of my equation, I've got the 3x cubed, and I'm going to just go ahead and write this guy second, minus 9x squared, and then this guy, minus 30x. So I kind of just reordered it as I wrote it, because I know I want my x's to go from greatest power to least power. So now let's start factoring this. We're going to factor the left side here. First, we want to ask ourselves, is there anything I can take out of all three of those terms? Well, I think all those numbers are divisible by 3, and they all have at least one x, so we can factor an x out of all three of them. So on our first one, 3 divided by 3 is 1. I've got x to the 3. I took an x, so I'm left with x squared. On my second one, I've got negative 9 divided by 3. That's negative 3. He had x squared. I took an x, so he's just left with an x. And then in my last term, I've got negative 30 divided by 3. That's negative 10, and I took the x. So now we've just got this equal to 0. It's looking a little nicer. We factored something out of everything. Now we just need to factor what's in those parentheses, because I definitely can't get x by itself still. So let's see. This is just normal factoring, right? We need to see what multiplies to negative 10 and adds to negative 3. So I could do 1 and 10. I could do 2 and 5. I think 2 and 5 is going to work here, because I could do 2 and negative 5, and that would add up to negative 3. So I've still got this 3x out here, and then this is going to factor to x plus 2 because of that, and x minus 5 because of that. Now I'm completely factored. I've got three factors, 3x, x plus 2, and x minus 5. If any of those three factors are equal to 0, the whole thing is going to equal 0. So we want to know, when would 3x equal 0? When would x plus 2 equal 0? And when would x minus 5 equal 0? So let's start with the first one. 3 times what is 0? Well, 3 times 0 is 0. So x is 0 is one of our answers. What plus 2 is 0? Well, negative 2 plus 2 is 0. And then finally, what minus 5 is 0? Well, 5 minus 5 is 0. So on this one, we got three solutions, and that's fine. Our solutions are negative 2, 0, and 5, because I want to write them out from least to greatest. All right, I was going to do some word problems. I think I'm going to stop right there, and we'll talk about the word problems in class. So just come to class ready to work on some problems like this, and you're going to do some problems where you have to write it out from a word problem and then solve it by factoring.